Can you hear me?
Yes, I can hear
Hello?
you.
Okay,
How's your day
got you.
been?
Yeah, it's good. How are you? I'm. How about you?
Very well, thank you. I have been studying programming today.
Oh, is it really hard today?
I'm starting to understand it better. I think it's more difficult when you first start
Mm-hmm.
because it's like learning a language. There are a lot of things that are hard to understand about it, but then you use the same things that you learn again and again, and it starts to make a lot more sense.
So what's its program you studying right now? What's language?
Java.
How and what language you use? English? Uh,
Oh, yes, yes. You use English to program, and it's called a programming language too. So that's
oh,
why I
okay.
said Java
Yeah.
because
Yeah, yeah. I got you. Uh,
have you ever had any? Oh, yes.
Yeah, I would like to talk about the article you gave me last lesson.
Oh, yes. Did you like the article?
Oh
I think it had
yeah,
some very nice photos in
yeah,
it.
yeah. It I love and I have chance to see. It's not like a ring fire, a Nula scholar Alice, but in my country, I I used to see a nular is covered like the moon is covered or the sun in day, so the sky is dark when I was kid. But I just read it about that article is have a ring light in it's happened in American.
Oh, a lunar eclipse. Is that what it was?
A nular
Let me see.
solar eclipse.
Oh, yes, the annular solar eclipse. Um, yeah, I mean, that's an amazing photo that they have there. I know
Mm-hmm.
that it happened a few years ago in the United States and it covered the West Coast because I think
Oh,
it'll only happen in one area.
oh yeah.
But
So, have you ever seen that before?
that's a good question. I know you're not supposed to look at it. I can't remember. I don't know if I was in the right place for it.
Oh yeah.
And did you get any photos of the eclipse that you saw?
No, in my memory, when I was kid, at that time I don't have any phone. I heard that on TV
Oh
today
yeah.
when I had a Nula Scholar script asleep. But when I playing around and the sky is turned almost dark and people, they told each other to see it and I have that experiences when I was kid and up until now when I heard people told today it have that happen. I'm not interesting too much because it's sometimes I work sometimes you know it happened in the night or maybe like that.
Oh yeah, so you can say when I hear that happened, uh, I'm not usually too interested in it.
Oh yeah,
Something like that.
yeah,
Um, of course, I understood what you were
yeah.
saying, but that'd help
Oh yeah.
make it like very clear. Um, yeah, I remember when I was a kid, we had they told us not to look at the eclipse, and I think I was 4 or 5, and they had us make these little boxes with a
Uh-huh.
pinhole in it, and then you could look in the box and see the
Oh,
eclipse.
okay. Yeah.
Have you ever
Uh,
heard about those?
no, I never heard about that. And any experience about that. So you watch it on the boards?
Yeah, like you put a hole in a box
Mm-hmm.
and uh the sun goes through the hole
Uh-huh.
and you can or the shadow and the sun go through the hole and you can look inside and you can see the eclipse.
Oh, okay. So it's not like you look it directly, you look it indirectly, right? Okay.
Yeah, but it's you can still see it.
Oh, okay.
It's just it's not you don't look at it with the box. You hold the box down
Mm-hmm.
here and the
Oh,
eclipse is behind you
oh,
and you can see sort of what it looks like.
oh, nice.
It's interesting.
Yeah, and one thing is about Milky Way. I saw a lot of picture, really beautiful. They talk about Milky Way, and that's beautiful. But I think it's have to more communicate to to have a telescope or
Oh,
binocular to watch it.
can you say that one more time? I'm sorry. It was hard to understand.
It's complicated to watch it because you have to got telescope and binocular to watch it.
Oh, yes. You need a telescope and binoculars to watch it.
Binocular, yeah, yeah. And one of my friend they have like a telescope. They can take a picture where and you need to to catch it. It's like you go to the mountain in the dark night, uh, like camp, right? Usually it's use the word camp. Like you wait to look, it appear in the sky. You wait the best
Oh,
time to catch it.
oh, and you said cam. I'm
I don't
not
know which
sure.
word to describe that accent, but
Oh, the best moment to catch something? Is
yeah,
that
yeah, yeah, yeah. Like something where you wait to buy something. The shop is Ramos is that time is gonna release this product, and you wait at that time to catch it. How to call the action?
Oh, I'm not sure. I know what you're talking about.
Mm.
You're waiting for the right moment.
Oh yeah, yeah, right.
Is
Yeah.
yeah. So
Is there a
maybe that's
word?
that's
Yeah,
probably
yeah.
is there a word for doing that
Yeah, yeah,
in
right.
Vietnamese? Oh,
Yeah.
there. That's interesting. So so we have to wait for the right moment to capture the
Capture the
photo.
product. Yeah, right. And this one I is remind me that I really interesting about one phenomenal nature happen in around North American or in Europe. This is Northern Light. Have you ever heard about Northern Light?
Oh yes, the Northern Lights are amazing.
Yeah, yeah, that's
Really,
so
really amazing.
amazing. It's magnificent, I think 2 years ago when I was in Georgia, I read the article. Tonight it will happen, not a lie. You can see it on Missouri or in Canada, uh, some of state in United States can see it. And when I saw a picture, I really amazed about how it's low. And I do some research because in my country we never heard about this. It's only have it's only happened in some area in North American or some South, right?
Yeah, I don't know. It might. I wonder if it happens in the southern hemisphere too.
Mm-hmm.
Um, I'd be curious to know. Let's see. Uh, I've only seen pictures of it. I guess that's yeah. They do call so there are two names for it: the aurora
Yeah,
borealis.
aurora borealis.
Yeah, and the northern lights.
Yeah.
So I think since they call them the northern lights, they probably do just happen in the north.
Oh yeah,
But there you have a
yeah.
little
Aurora
reminder that
borealis. Yeah.
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 I want to check. Does it happen in the south too? Oh yeah, it says it happens in the south, but there it's called the southern lights.
Yeah.
So it does happen.
Because I saw a video talking about the scientist he find how it's happened and how it's caused to the northern lights and
Oh,
is yeah.
oh, you said they found how the northern lights happened and what causes them?
Yeah, yeah. Uh,
Oh, okay. Oh, yes, please.
okay. Yeah, because it happened from the sun when it have a lot of electronics come into shooting from the sun to the earth, and when it go to the weakness magnetosphere of the earth from the north and the south is when it's associated with oxygen and nitrogen, it create a color. It depends on how the oxygen or nitrogen.
Oh, wow. That's amazing. Did you say it depends on the oxygen and nitrogen
Yeah, yeah,
in the atmosphere?
yeah,
Wow. I knew it was connected to the magnetic field
yeah,
of the earth,
yeah, yeah, right.
but I didn't realize yeah, I didn't realize that it was the sun that was causing it.
Yeah, because the
That's
sun
really,
is
really
too
cool.
hot. Yeah, and it's the sun have like for state material, gas, liquids, solids, and plasma. And in plasma, it have electronics and iron. They moving and a lot, and it's make like really affect from when the sun is shooting dust, electronic, and iron to the earth. And when it's come to the earth, it's for if they come from it have the earth have the magnet store, right? Which is
Magnetic field.
a magnetic field is prevent that electronics in an iron. But when it come to the south and the north, this is the weakness place in the earth, so it come when through that, and when it is meet the ocean and nitrogen, is create a photon, and the photon is a light. We call this photon.
Wow. Yeah, so that's where the lights come from. That's really cool.
Yeah, and it depends
I
on
didn't know that.
yeah, yeah. It depends on how the higher of the ocean and nitrogen. If from 150 mile, it's usually create a green, and the Boris a red, and then that's purple, and sometimes it's mixing together.
Oh, wow. So if the molecules are higher up, it might be a different color. And
Yeah,
if they're
yeah,
higher up, it's another
yeah,
color. That's so interesting because that is really similar to how colors are created by LED
mm,
displays.
yeah, yeah,
Like on our oh, not the LED display, actually. I think it might be do you know how, on some computers the keys have different colors that they light up with. Have you
Oh
ever seen that?
no, I never. I know. I saw the RGB the color, but I don't know how it's created. You know.
Oh, yes, yeah. So you know the RGB. I couldn't remember the term.
Yeah,
Good
yeah, the
job.
RGB.
Uh,
Yeah.
yeah. So with those RGB colors, it has to do with. Uh, I think it's where electrons are, because in an atom they can go from one orbital to
Hmm.
another orbital
Yeah.
depending on the energy, and something about that is connected to which color
Yeah.
comes out. And I can't remember it right now, but it's very interesting. I think it's connected to that. I keep trying to read about it to
Oh yeah.
understand it, but it's very hard to
Yeah. Yeah.
understand.
Yeah. Some word is really hard to understand if you're not interested in the life because northern life is really amazed me when I saw it. So I just feel interesting. I do some research about it.
Oh yeah, yeah, yeah. I'm really amazed about it too. Well, like what they said about I like the Northern Lights and the RGB keys, because what they said about those keys that was really interesting.
Oh, just connecting down. Oh, man. Uh,
Oh,
I
there it is.
okay. My Wi-Fi is
Oh, I can't
yeah.
hear you. 1 second. Let me see.
What? Let me check. Why my Wi-Fi is nice. Let me change the Wi-Fi.
Oh, it shows that I'm talking.
Can you hear me?
Ah,
Hello?
I don't know why I can't hear you.
Okay, one second. I'll be back. Hello? Hello?
Oh, hello. There we
Yeah.
go.
My Wi-Fi is going down.
Oh no.
Yeah,
I'm
yeah. I
glad
just
it's
changed it.
working again.
Yeah.
I noticed that the little screen lights up with a blue box if it
Oh,
can hear you.
yeah,
Just
yeah,
in
yeah.
just in case you ever need to know that for later.
Oh, so
Because I was
yeah, I couldn't follow you. What did you just said?
Oh yeah. So I'll tell you what I was going to say is that I can give you some interesting details
Mm,
about the RGB keys, but some of what I say might be wrong. But the
yeah,
big picture will have some of the things you'll hear again if you go
yeah,
read about it.
yeah.
But what I remember being very interesting is that they said that they have the electrons for the
Mhm.
RGB lighting, and they
Mhm.
need those electrons to essentially fall into a hole.
Oh,
And when
okay.
the electrons fall into a hole, it releases a photon. And so the more
Okay.
energy that the electrons have when they fall into the hole, the more energy of the photon that comes
Oh,
out.
yeah, yeah, yeah.
And, and what they do is they force the electrons to go into those holes. And that's the part I can't really remember, is how they force them into the holes. But when they fall in the hole, it then has the electron and the photon comes out, and they can control the whole thing. It's not like random at all, you know?
Oh,
So
okay.
it's really interesting.
Oh, so that's similar with the photon on the northern light, but in northern lights we cannot control it because it's random, and that's why we see it moving in like the sky is boiling when it appear the northern light. and people use like you said, people use that like to make a hole and keep their electron in in that, and it create a photon, right?
Um, there is a. Are you saying that there is a hole for the Northern Lights too?
No, no, no. I'm saying like you said, the RGB people they make like the hole and keep the electronic on that, and it's make the photon come from that. It's not random.
Yeah, let me see super quick. So they have something called an electron hole,
Mm-hmm.
which is a space for an electron. It's
Oh, okay.
missing.
Okay,
It's
yeah.
missing an
Yeah.
electron. And so when an electron drops into the hole, it goes from a very high energy
Mm-hmm.
state to a
Mm-hmm.
lower energy state. And when
Okay.
it goes into that lower state, a photon comes out that matches it.
Yeah.
The f- and so the amount of energy the electron lost is equal to the amount of energy in the photon that comes out. And
Oh.
so if the electron lost a lot of energy, it might be purple comes out. If it lost a little bit of energy, then it's red that comes out. So that's the best way that I can describe that. And I hope I'm not getting that wrong. Uh,
That interesting.
yeah, it says, oh, oh, actually, it looks like there's a gap. Oh, okay. So the distance the electron falls is
Mm-hmm.
called a band gap. And if you make that distance that the electron falls longer,
Mm-hmm.
uh, then the higher energy of light will come out, which
Oh, okay.
that's very hard to
Oh,
understand.
yeah.
I would think
Yeah.
my thought would be if it falls a longer distance,
Mm-hmm.
then the energy would be lower because it used
Okay.
energy to go
Yeah.
that far. But it's very interesting. I want to learn more about this. I
Yeah.
just it's so hard to understand.
Yeah.
I hope you might like to read more about it as well, and maybe you can explain it to me because I really liked your explanation of the aurora.
Yeah. And that interesting because I when I drawing art and I make a color, it's usually use a lot of like RGB or RYB to create this, and I know about the light, uh that is maybe related about electrons. I know it. So how about like you said you lie about quantum physics? There's relate to like the magnet fear about the Earth.
Yeah, yeah. There are a lot of different things to learn about in quantum physics,
Mm-hmm.
and there are certain areas that I understand better than others. But as I understand it, because the Earth in its core has a lot of magma
Mm-hmm.
flowing around, it's got metal, that's flowing.
Mm-hmm.
That I think generates
Yeah.
the magnetic current for the
Mm-hmm.
sphere. Um, but I don't know about like the specifics of the aurora
Okay.
borealis
Oh yeah.
at a quantum physics level. But what
Yeah.
I've learned a lot about is things like how particles, what rules there are for particles. Like for example, there's something called the Heisenberg uncertainty principle,
Mm-hmm.
and what that shows is that you can't know the location and the momentum of a
Oh.
particle at the same time.
Okay.
So uh, that's very interesting because how can I say this? There's something I want to tell you about it, but it's very hard to the way to say it is this, like, the faster a particle, the better we know the speed a
Mm-hmm.
particle is moving,
Mm-hmm.
the
Mm-hmm.
less we know about where it is. And the better we know where it is, the less we know about how fast it's going. But what's
Oh.
really interesting about it is it's not because our instruments can't measure it.
Mm-hmm.
It's actually a property of physical space.
Okay.
So if you knew the location of a particle perfectly, uh, sorry, if you know the speed of a particle perfectly, then it is mathematically at all points in space. It's everywhere all at the same time.
Oh, okay.
There's there's no way to actually know the location or the real speed of a particle. You can
Mm-hmm.
only know what it might be. You can only know a general range. It's really
Oh, yeah.
interesting. And it's
Yeah.
just because that's how space is.
Yeah.
You can't you can't know things. The more you look at them, like you don't find like here's this thing
Mm.
is here and
Mm.
this thing is here. It's more like space just stops working the way we
Yeah.
think.
Yeah. Yeah, so so you see the more you know the location is the less you know about it, right?
Yeah. The better your information about its location, the less you know about its speed,
Yeah. Oh,
about how
okay.
fast it's going.
Oh, okay. Ah,
And so i- we might want to think of things being in a specific location when
yeah.
they're really small, but there actually isn't really a specific location for anything at very
Yeah.
small levels.
Yeah.
We can think it might be here, or it might be here, it might be here.
Yeah. Oh, that's
It's,
interesting.
yeah, it's just really interesting that that's not because we need better instruments. It's not
Yeah.
like we need a better magnifying glass, you know.
Yeah.
It's just that with things that are that small,
Yeah.
location doesn't really work the way that we think it
Oh,
does.
yeah. Yeah. And so it's how about we think about that, not like we know about it, right?
Well, that's the interesting thing is they actually do know this, and there's
Uh-huh.
an equation for it because let me see. The equation is let's see if I can understand. Well, the interesting thing I can say about it because the equation is hard to talk about is that wow, what was I gonna say? Oh, I'm sorry, I forgot what I was gonna say about it. But the interesting thing is that the way that particles work,
Mhm.
how do I say this? Momentum, like how fast it's moving,
Mhm.
and its location are exact opposites.
Mhm.
And so if you increase the momentum, you
Mhm.
decrease how much you know about its location. If you increase what you know about its location, you decrease what you know about its momentum.
Oh, so it's
And tho-
opposites, maybe.
yeah, and that's not because of the instruments, it's because of the particle and the way that it connects to physical space.
Okay.
Because if you think about location, location tells you about space. If
Yeah.
you think about momentum, momentum tells you about a particle.
Okay.
But for quantum physics, particles and space are kind of the same thing.
Oh. Oh, interesting.
And that's why you hear about like dark energy and dark matter and virtual particles, where they
Mhm.
say, if you ever hear about virtual particles, they say that. particles are coming into and out of existence all the time,
Oh, okay.
like constantly.
Yeah.
And that's part of the math. But they say that they're not real,
Mm-hmm.
but they're also like in the vacuum of space,
Yeah.
and they're in the math that they use. And so they're important. They're not just imaginary. It's very, very complicated.
Yeah, it's
But if
more
you see that,
complicated. Yeah. So
but yeah,
do you,
look.
are you still study about that, or do you want to to study and be an expert about this, or you just want to know?
I just want to understand. Yeah.
Okay, yeah,
I like to read the articles and be able to hear it, like what they're
yeah.
saying. And do you have an interest in that too? It seems like you really like science as well.
Yeah, I just heard about this, and I see I never think about this before, because when I was um I I really like about mathematics when I was kid, and I miss it when I go to high school. But I think I really good at math when I was kid, and about drawing. So you remind me a lot about that's called physics. Uh, in subject in
Quantum
Vietnam,
physics.
yeah, we call physics, and physics is the subject interesting for me when I was in the first high school. Then later I missed it. So maybe they are something I never know about this, but maybe when I read this, I will uh, have like make me feel make me feel how to say this make me feel to interest with this.
Oh, it makes you feel, it makes you realize that you're interested in it.
Yeah. I want to say a different word because I use that interesting a lot. So I want to really find another words to fix that.
Oh, okay. Here, I'll come up with an alternative.
Yeah.
You can say I'd like to know more about it, or it fascinates me.
Fascinate me.
And
Okay. Okay.
yeah, it's a
Uh,
fascinating
oh,
subject. You can also say.
I like to know more. Okay. That's more ways, more easy to say.
Um,
Yeah.
yeah, so I'd like to know more about it is similar to it's interesting to me, and it
Okay.
fascinates me means it's really, really interesting.
Oh. So fascinate is more strong emotion, right? Like,
Yeah,
okay.
yeah, it means you're very focused on it,
Okay.
and I think it's fascinating.
Yeah, yeah, yeah. That's fascinating subject.
Yeah, um, I'll send you an article about the Heisenberg uncertainty principle,
Okay.
and then so you can read more about it,
Yeah.
so you can learn about momentum and location and how those are connected,
Okay.
uh, and hopefully it'll make sense and you can translate it to Vietnamese. Okay, um,
Yeah.
but and then you can see the terms and learn about what I was trying to say.
Yeah.
It's also complicated. It's very, very hard to
Yeah.
like really understand it. I just know the principles, but I'd like to understand it very, very well someday.
Yeah. Do you do you know about this on the school, or you know it when you read the book?
Oh, I learned about it. There's a YouTube channel from a
Oh,
professor
okay.
at a New York university, and he talks about it. He talks
Oh.
about quantum physics, and I learned from his channel and a bunch of other ones. There are a lot
Mm-hmm.
of like science and math channels on YouTube.
Mm-hmm.
Uh, I can send you his channel. They actually have very good subtitles
Okay,
on
that's
YouTube to
good.
translate things.
Yeah, they have a lot of subjects about in that university, that professor, or they is he only say about quantum physics or
It's this show. It's called PBS Space Time, and
PBS space time. Okay.
yeah, and it's really fantastic. He does a great job of explaining very complex things, and there are a lot of visuals that
Mm-hmm.
go with them that help a lot to understand what he's talking about. I think the hardest thing with quantum physics is just being able to imagine it.
Mm-hmm.
And so his videos really help a lot to imagine what he's talking about.
Yeah. Yeah, I think it's how is amazed when I was growing up and those thing is boring in the school. Now go to the when we grow up we tend to find that subject to learn about it, because when it remind me that when I was in kid in Vietnam, we usually learn about some subject about physics or it's about mechanic or any type of scientist. They are boring because we don't have like practice. We usually it's comprehensive. In Vietnam, we it's like English. We just learn grammar and just make you memory, try to memory, and that's make you feel more boring, uh, to and lost the interesting into it.
Oh, so you could say you have to memorize it
Oh yeah,
and
yeah,
try to remember it, and you have to not lose interest in it.
yeah,
Can't remember the last thing you
yeah.
said. I'm sorry.
And not to we don't have like practice like comprehensive to see how it's work in real life, you know what I mean?
Uh, yeah, yeah, I know what you mean because you don't have the context that you
Yeah,
need.
yeah, yeah,
And then once you get that, you go, "Oh, this is very interesting. Like I actually am
yeah,
interested and it's teaching me a lot."
yeah, yeah. It depends how the teachers explain it. That's maybe it's complex,
Yeah.
but the teachers don't know how to it's work, but they just remember and teaching on the book, and make the student feel boring. That's a lot is the fascinating in that subject.
Yeah. So you say they force students to memorize and just teach from the book. Uh,
Okay, they force
yeah, and
them.
so
Yeah.
yeah, and so you're right. Like people are just putting the same. They're putting an idea in their head. They're
Hmm.
going, "I have it. I can say it back like a tape recorder or
Oh
something
yeah.
like that."
Yeah, yeah. Yeah, that's
And they don't
exactly.
really they don't really understand it or know why it's
Yeah.
interesting. I had a science teacher who said that science could tell us about the universe, but it was like a black box that we were just you could shake the box around and you could poke it, but you couldn't really know what was inside.
Hmm.
And for me, that made me sort of like not have an interest in
Yeah.
science. I was like, "Oh, well, they don't know anything, so what
Yeah,
does it matter?"
right. Yeah. And even
And then
when
later,
students are curious asking about how it's work, they cannot explain it to us. So yeah,
yeah, but later I found out like they know a crazy amount of stuff. It's actually like insane how much they actually know.
yeah,
And so it's really worth learning about science because they're just over there doing their own thing, but man, they're like finding out the most interesting answers to questions.
Yeah.
And it's like that equation that I was talking about, where location and
Yeah.
momentum are directly connected. It's so funny that those things have a relationship like that for space and energy, like connected directly to each other.
Yeah.
And it's like the fact that they know that, and it doesn't have anything to do with our equipment. It's
Yeah.
just so amazing to think of, because you'd think like, oh, we just need better equipment, then we'll be able to
Mm.
see the particle, how fast it's going and where it is.
Oh yeah.
uh, but it's like, no, space won't allow it.
Yeah.
And the speed of light is the fastest rate that anything can happen at, so they call it this too. And that's one of those very interesting
It's
understandings that
a
I think,
costly.
yeah, causality is a change that occurs, something that causes a change. And
Oh.
so the speed of light is the fastest that any change can happen. And there was another experiment where they found gravity waves
Yeah.
that came from two black holes that hit
Yeah.
each other. And we could see the gravity waves from that here on Earth. And what was so interesting was they found the speed that those
Yeah.
waves moved at. Have you ever heard about the speed that those gravity waves move?
No, I heard about gravity, but I never heard about that term about speed of gravity and that's uh it's about who is five Newton.
Oh, can you say that one more time? I'm sorry.
Like Newton is the for gravity speed.
Oh, yes. But what was very interesting about the gravity wave, because that wasn't about the speed of gravity, that was about how quickly objects fall.
Okay.
Force equals mass times acceleration. Uh, but when scientists looked at the black holes
Hmm.
that slammed into each other in the depths of space, what they did was they had the world's most sensitive laser,
Oh,
and they could
okay.
see it shake
Hmm.
when the black holes collided. And what they saw was that our telescopes could see the black holes hitting each other. They could see a flash of light.
Hmm.
And in almost exactly the same moment, the little laser shook and the gravity waves hit the earth. So it means that gravity waves travel at the speed of light.
Okay. Yeah.
Yeah. So that's a really interesting thing to look
Yeah.
up and learn about.
That's really interesting.
Yeah, so would you like me to send you an article about the Heisenberg uncertainty principle that I mentioned?
Yeah, yeah.
And it's,
You can send me that and any subject you like to me to talk about this. I can read this and your article is really interesting. I never heard about this. It remind me a lot of experiences I have in my life to study all this.
oh, I'm really glad you liked that one too. Yeah, I thought those planets were so cool. I mean,
Yeah,
the pictures were so cool of the moon and everything that they took photos of. I love the National Geographic. It's
yeah.
a great magazine.
Oh, do
Um,
you like geography? Geography?
oh,
Mm.
I think it's sort of interesting. I look at the locations of
Oh,
nations on the map to
hmm,
know where things are. Is
yeah.
that geography, or am I getting confused? I like nature a lot. I think
Oh, you like
nature is
nature? Oh,
really,
nature is good. Yeah. Yeah, we can talk about nature, about quantum physics, about anything about nature.
Oh, well, I will certainly look forward to it then,
Okay.
Michael, and I'll send you some articles, and those are some wonderful subjects. So
All
I
right.
really appreciate
Yeah.
getting to
Thank you
talk
so
with you
much.
about them.
Yeah, I really enjoyed that conversation. All right. Have a good day. See you
Oh,
later.
wonderful. See you then. I'm sorry if I took too much time talking and you didn't get the chance to practice
No,
speaking
no,
as
no,
much as you wanted.
no. Listen and speaking is also the same time. It's helped me a lot.
Oh, fantastic.
Uh,
I'm glad. And I'll still try to make sure
All
you have
right.
plenty of chances to practice speaking next time. Have a
All
great
right.
day.
All right. Likewise. Bye.
Thank you. Thank you so much. Bye.
Bye.